Here's the culmination chapter for Biology 20A. It's the first half, ends the first half of our semester. For those of us in UC Berkeley Anatomy Lab, this is also the midpoint of our work, and it's very auspicious. The autonomic nervous system, I've listed it here as part 1, page 525 in this particular edition of Merib's Anatomy and Physiology. And here, just to see sort of where we are, we're not in the central nervous system, and we're only in a portion of the autonomic nervous system, and we're fundamentally, although we do have feedback systems here quite readily available, we normally think of this as a motor system, although we do have the beauty of vagal reflexes and all kinds of other things. This is largely overseen, and we'll see that the big boss here, literally, as Dr. Merib states it, the big boss is the hypothalamus and the set points of the hypothalamus. So we don't normally, unless you're really fabulous at becoming one with your art or your sport, or you are a shaman living outdoors in the forest, or you're a master of meditation, most people do not have all that much conscious control over their autonomic nervous system. Some of us have practices that we, how shall I say, perfect over a lifetime. And it's wonderful. I would say that we're only as good as our daily practices. And so we are able to, how shall I say, balance and synchronize our fundamental homeostasis in positive ways. So if you can do that, wonderful. And, study that as much as possible, please. I have my sort of opus from medical school. This took me several semesters to put together. I began working on it as the top anatomy student in my medical school class. I managed to finish the class at the top so that I could, they have promised me a position to teach if I could manage to do that. Anyone who finishes generally in the top 3 gets to teach the lab the next year. So this got rid of my tuition. I didn't have to pay tuition at my medical school in the 1980s. And so since I didn't have to worry about that stuff, I decided to put a lot of extra work into this. And as I dissected and we found things, and as I studied, I began to put together the bits and the pieces of everything to do with the autonomic nervous system. So I want to show you this big overview. Basically, here's the central nervous system, and we have the cell body in the central nervous system, and we have the fiber that flows out, and then it has to go to a ganglion, a second-order neuron. So this is basically a 2-neuron system. First neuron, cell body, and fiber exiting, so the axon. Here's the synapse for the second-order neuron, then the fiber, the axon outflows, and then here's the target, or the outcome. So you'll all have this that I'm going to give to you. I did a little bit of drawing as well, and because the way the systems are set up is that in the human body, the sympathetic system is in the middle. It runs in the spinal cord from its origin for this first generation, first order neuron. The cell bodies are all in the lateral horn of T1 to L2. T1 to L2. Okay, right here in the lateral horn. This is supposed to represent the spinal cord. So right here is that first motor neuron, which is going to exit, and we'll talk more about all of the different ways in which it moves around, but it's in the spinal nerves of T1 to L2 as it first exits. Okay, and then there's a number of possibilities in which it arrives somewhere at a ganglion here in the body. This is the one part of the system, however, that is also more than 50% endocrine. And part of the deal is instead of going to a hardwired situation, is that the sympathetic nervous system actually goes to the adrenal medulla, wherein more than 50% of the output, in most cases, becomes bloodborne. That is to say, the epinephrine, which in the hardwiring would be the neurotransmitter that reaches out to the target, whether it's the heart or the eye or the sweat glands or wherever we're going. Instead of having a hardwired situation, most of the time, over 50% of a significant sympathetic output is actually going to be epinephrine here in the adrenal medulla entering the blood. So it's actually a hormone at that point. So we have a little blur here with epinephrine as a neurotransmitter, hardwired, epinephrine as a blood-borne hormone. So, and we have to wait for it then. So if you get cut off in traffic at some point or another, or something happens to you and you can't really take a walk around the block or metabolize that so easily, you'll have to have those wonderful daily practices that you've been practicing in order to smoothly render yourself homeostatic and balanced and synchronous in the midst of significant sympathetic output. On the other hand, it's always a good thing if you're practicing your exercises, because it's wonderful to have a little body buzz after your run or your tennis game or whatever it is that you do that's aerobically inclined. It's kind of pleasant to have that little buzz at the end. It means that you had a really nice workout. Meanwhile, here we have parasympathetic. I have it with the P's here. And then down here we have parasympathetic. So we have what's called a cranial, these are cranial nerves. Sacral, these are sacral spinal nerves here, outflow. So the cranial nerves of interest here are cranial nerves 3, 7, 9, and 10. 3, 7, 9, and 10. And there's more than one. There's a little bit of branching going on there, so be prepared for that. And then out here we have S2 to S4. And that's the reason for that is that 10 only goes down so far. 10 will get your digestive system working all the way from the esophagus and stomach through the small and large intestines until you get over just underneath the left rib cage, and then the descending colon down to the rectum. That, unfortunately, for those with spinal cord injury, is not going to be innervated by the cranial nerve. Instead, it's going to be innervated by the nerves at S2 to S4. And if the spinal injury is above S2 to S4, that means that the descending colon and the rectum no longer have function or sensation. And so that just means that the digestive system kind of slows down. The good news is that we don't really absorb that much on the descending colon and in the rectum. So it's just a matter of how do we get our patient to go to the bathroom if they are a wheelchair-bound individual with that particular problem of a spinal injury. So that's something we'll take a look at when we get to that portion. So this is just the big overview, and all of this is hardwired, and it's with acetylcholine. All of this is hardwired with acetylcholine. Some of this is hardwired, the sympathetic here with the S. Some of this is hardwired, and where in fact most of it is actually hormonal. And we do have the bloodborne situation. So that's the big overview. Then we're going to be having a, shall we say, another big overview here. And I like this page because I get to, and I'm going to come back here in this second part because I want to illustrate much here. This is the autonomic nervous system. Sympathetic over here, parasympathetic here, and they are good enough in the book to distinguish between what's hardwired. Do you see 2 neurons going to a target synapse? Then here's the first order neuron going to the adrenal medulla, and we go to the blood, not to a synapse. Well, we're going to get to a synapse, but we're going to get to all the synapses, if you know what I mean, because the blood gets to go everywhere, right? Because it's Meals on Wheels, and it's going to be actually seeing all 50 trillion of our cells, right? And so that's part of the deal. So that's the other part of the big overview here is that they're comparing that to the regular somatic, how shall I say, muscle neuron here, motor neuron, which is a single device that goes out in synapses from the spinal cord to a muscle, and it uses acetylcholine. Okay, let's come back to this in number 2.